how to empower your teams with Pulumi's internal developer platform. For today's agenda, first, I'm going to do a little bit of thought leadership and talk about platform engineering in general as a discipline and how we at Pulumi think about it. Then we're going to do a breakdown of the components of an internal developer platform. And next, I'll show off Pulumi Cloud's IDP offering that you can start using today. And after that, we'll have a bit of QA and we'll just wrap things up. So let's start with some of the essential characteristics of what platform engineering is. I'm intentionally going to try to differentiate platform engineering as a practice from an internal developer platform, which is an artifact that your particular organization's platform engineering efforts might create or make use of. I'm going to propose to you a journey, an evolution to a level of sophistication that you can get to in your organization's platform engineering efforts. To start, some of the essentials of platform engineering as a practice. There has to be at least some level of self-service. That can range anywhere from a centralized team writing the infrastructure as code for someone up to a full-blown no-code point-and-click interface on the web. I'm going to dive into those with 3 patterns that we see commonly in the field and which might be the best fit for your org. We'll figure that out with you. But this is a key point here. There has to be some level of self-service, right? If all the workloads your app teams are deploying and caring for and feeding is writing their own infrastructure as code, you're probably not doing platform engineering as described. There's no centralized teamwork there. So I'd say that a platform team is essential to platform engineering. It's also kind of in the name, right? So second, there needs to be some level of abstractions present that makes it easier for application teams or consumers of infrastructure to follow certain golden paths. For example, this is our organization's template of how you would run a Kubernetes cluster, or here's an infrastructure template for an app that runs on virtual machines with auto scaling, something like that. So these blessed infrastructure abstractions, your platform engineering efforts need to shift security left. What do I mean by shifting left? You hear it a lot, right? These infrastructure abstractions should, at the minimum, expedite any sort of security concerns. You need to bake in those secure practices, call them guardrails, if you will, into whatever it is that you're handing off downstream to development and application teams. We call these golden paths, concrete representations of workloads. We call them services. So I'm going to try not to use workloads and services interchangeably from this point on, but just keep in mind that during this workshop, the workloads is the more general term, while services is that golden workloads, that golden path in Pulumi IDP and throughout. Who knew? Naming is hard. Okay, so when I say you want to shift left, let's assume originally security review happens at the end of the process of deploying a service to production, okay? So if you were from my time in the older, more waterfall, less agile, single long dev cycle, you're going to see at the very, very, very end, security could come in and say, let's see your work, let's review it. And then they're going to start asking you questions like, okay, what libraries are you using? Do you have an SBOM? What's your bill secure software bill of materials? Are they secure? What's the network access you're allowing? Things like that, so on. So you want to move that security stuff earlier in the process, but not too far left where you're just dumping this on your application teams. And they need to figure out all this stuff because those application teams, they don't have that expertise, right? To know what a sensible security group is, the network access might be. They may not be like true cloud experts or whatever. They could be just application developers. It's fine. So you're asking a development team to know way too much of the details of infrastructure when that's just not their focus. The development team wants to ship services that do some sort of business function, like they're making money for the business so they can keep getting paychecks and not have them worrying too much about network security, for example, because there's only so much cognitive load there and only so much expertise that any group of engineers can reasonably have. So that's security shifting left. Now, your platform engineering efforts need to bake in some sort of operability. Rob, what do you mean by operability? So some sort of instrumentation on what your infrastructure is actually doing. Let's say data like VPC flow logs or similar that would help you operate a service on a daily basis, debug a production incident, ensure that you're able to fix things that happen in the real world outside of just your happy path integration tests. We'll get into this a bit in a future slide, right? So, how are you going to get these templates instantiated into production services or the series of environments before you hit production, like QA or staging? So, that's CI/CD pipelines. And the degree of smoothness and how much you're abstracting away and what the interface is, that's really going to depend on your organization's needs. We here at Pulumi came up with three patterns that are part of the spectrum of self-service, and the sophistication increases. It's more practice, it's more scalable, it's more refined as you go from left to right on this slide. And then the burden on the platform team and the skills and the sophistication that the centralized team or teams. Some orgs, you may have multiple platform teams. They have that sophistication becomes the responsibility of the platform team, and the skills they must have also increases as you go from left to right. So the first pattern on the left there is the simplest, and that's IAC factory, or infrastructure as code factory. This is very common, for example, let's say startups, smaller tech companies, or just even organizations. It can even be common in some enterprises where an application team needs to deploy, say, a service, some reified infrastructure, and a centralized platform team, which might be titled DevOps engineer or an SRE or something, but someone who has infrastructure expertise is going to write that infrastructure as code on behalf of the app team. And they might hand it off, or they might just run it themselves, spin it up in Pulumi Cloud, whatever. This is better than just point and clicking in some console like at the AWS console. It's not the bad old days of, okay, so go submit a ticket, app team, we'll get to it. We'll look at it, and at some point we'll get to it. You're just going to have to wait. It's a manual process. Sorry about that. So it's better than that, right? But it's also not scalable at some point because you're not really abstracting anything. You're not getting a ton of reuse out of the work done. So if someone leaves, that institutional knowledge will go with them. They had all that expertise, and poof, they didn't really write it down. It's maybe somewhere in a Git repo, but not so much documentation or anything like that. But it's a good starting point. So that's the IAC factory pattern. The next pattern that you might see, and probably will see the most, at least right now, is what we call templates and components. I think this is where most organizations that I've worked with fit. In my career, I've mostly worked around Fortune 500 enterprises that are not necessarily in the tech sector. So it's like the technology supports what they do, but every company is a tech company for the past 20 years, right? But it's not their primary goal. It could be a company that's like in media or entertainment or manufacturing cardboard boxes, for example. But it's not like AWS, which is really tech from the ground up, right? There's other companies, the product's not specifically tech per se. They're not in the business of writing software. So what you see with templates and components patterns the pattern here is that this is a platform team. They're clearly abstracting things away that they found those patterns in. They're creating IAC templates. They have components, whether that's in Pulumi or Terraform or PowerShell or whatever. They probably have some sort of package feed, or they have a Git repo that has a bunch of templates that handle common scenarios. Something like, here's how here at XYZ company we provision a VPC. Here's how we provision a Kubernetes cluster, so on. And so that's sort of common infrastructure patterns. And those components may be updated regularly and maintained by the team, right? So the way that the app teams are interacting with those individual components or even the entire templates is that the app team will just fork them, and then they're responsible for maintaining that fork on their own. So if you have, I don't know, here's our blessed way of doing a load balancer. It's got security built in. It's maybe got some sort of cost control built in. This is how you should use a load balancer, right? So now the app team is going to somehow consume that IAC component to do a load balancer. And the app team is responsible for keeping their own infrastructure up to date. And ideally, the platform team should have some level of support, right? Um, Here's how you upgrade this stuff, but they're not doing the upgrade itself. They might dictate the platform team might dictate that, hey, you need to upgrade to version 2 of our load balancer component by X and X date, or it's going to become mandatory to use product Z because we need to make sure that we have this cost control or that security control in place. The app teams are just essentially responsible for updating that component in their code and making sure their own services keep working. So the app teams are maintaining that fork, and they're going to upgrade versions of components on their own. There may be breaking changes. The app teams are the ones who are just responsible for entirety of that, for resolving all of it, notwithstanding whatever documentation or maybe one-on-one help that a platform team might provide. And this works, right? It's a fine enough pattern. Most orgs that I've worked with, this is probably the pattern that they're using today. It's just one of the that tends to best fit their needs, given their available resources and the return on investment. It may not be the most efficient in the sense of leaving every single app team to their own devices and their own structures, but we're all doing what we can with the resources we have, right? So once you get to a certain scale, and we're finding here at Pulumi, like 4 out of 5 or so of our clients are looking into doing this, you have a whole department of app teams that need to move fast. The sheer amount of patterns is something that needs to be managed. So you don't have everyone doing everything bespoke. Using the big 3 clouds and the 3 different compute platforms of VMs, containers, and serverless. You discover that there's a sizable number of patterns across your org for the scale that you have. That's when an internal developer platform really starts feeling appealing. And so in an internal developer platform, you have that platform team, and they're going to create some registry of components and templates. And then the app teams are going to use that registry to deploy their applications as services. They can discover it and then deploy it. Oftentimes, your updates to the app infrastructure are centrally controlled, and generally, it's not your platform team pushing a button that upgrades everyone's Kubernetes clusters to the latest minor version. But that process of upgrading is fairly push button for application teams. So they might say, just go into a web UI and they'll change the Kubernetes version in a config from latest -1 to or whatever to the latest. And then they're going to push that deploy button. And then their Kubernetes cluster is going to be upgraded and they're going to maintain operability. Their service is not going to go down. That upgrade process is refined. It's refined enough to be smooth sailing. And everyone's happy. Everyone's excited. Break out the bubbly, all exciting. So these infra updates, these are probably going to be centrally controlled at that point, frequently in an internal developer platform. App teams may be able to fork the code and maintain it on their own, but that's one option that can be present. But more often, the default is we have this highly abstracted interface for you. It's typically going to be like a CLI or web UI where it's point and click, and that's how application teams are interfacing with the platform. In this internal developer platform, the level of abstraction and sophistication is higher than what you would see with templates and components. Everything's going to be well integrated. Just keep me posted. So when we talk about this slide, it's probably best understood as the IDP and layers, because just like platform engineering in general, we'll have a lot of these items built in, but this is really pertaining to an internal developer platform. And so we can see the way that we broke it down here at Pulumi. We broke this down into 4 separate layers that we feel encapsulate what the major components of an IDP are in terms of infrastructure resources and the code that goes into an IDP. With these layers in mind, we're going to go into each of these in detail from the bottom foundation up. So the first one is your foundational infrastructure. This is defined by your platform team, which we've labeled InfraOps, with input from security. Now, in the world of AWS, you may have heard this referred to as like a landing zone or baseline account factory, something like that. Different clouds have different names for what specifically goes into this, but this is the basic stuff that you get in every AWS account or Azure subscription. How it's actually sliced and diced or set up really depends on the cloud. So, for example, like with the Google Cloud, the network spans the entire globe. You set up a VPC. That VPC spans the entire Earth, essentially. In AWS, in contrast, it's very, very different. In AWS, a VPC is bound to a region and an account. So that's the AWS concept of an environment. But in either case, this is the foundation in each environment, and it can be parameterized differently, but it's always there. So what would you always want there? So first thing is things like security controls. So particularly if you're in a regulated industry, something heavily regulated, you would want to have security controls. Taking AWS as an example, a common requirement would be we want an AWS config role that sets off an alarm anytime there's a publicly readable S3 bucket. If you're not familiar with AWS, that just means anyone would be able to view these files anywhere in the world unauthenticated. And that's usually bad news, and it gets you in the news. So we want to have security controls in every account that will stop that from happening, because that's something we just never, ever want to happen. Another example would be if you're in the American health insurance space, there's a set of regulations in the United States called HIPAA. So it's a lot of cloud managed services that may or may not be HIPAA compliant, and you need controls to stop anyone in your org or for any reason to use those non-compliant services. You don't want to allow them to use it. They aren't in agreement with whatever your organization's regulatory compliance is. Another one is you can't run anything in a particular region because of, say, export controls or whatever regulations again. So that's security controls. When we talk about shared networking, for example, in AWS, a very, very common pattern is to use what's called centralized egress. So you may only want to allow traffic to leave AWS and go over the internet from one place. There's a couple reasons of why you'd want to do that. One, it allows you to set up a firewall so that you only have to put it in one place, only do it once. There's also multi-cloud patterns. So if you're using a service or something that's people are commonly using to allow private networking between clouds, you may want to put that in shared networking, that firewall in shared networking. Other things like if you have some sort of direct connect or something analogous to a hybrid cloud situation, like you need to allow your data center to talk to your cloud environment, that would be part of your foundational infrastructure. And then finally, controls like IAM. How do people or processes across access that cloud environment? That's something that's foundational in nature, right? So you want that to be consistent across each cloud environment. And so this is going to be managed exclusively by the platform team and typically via infrastructure as code. So it's fully owned and operated by your platform team, probably in consultation with your security team. App teams don't see this. They don't really care it exists unless they run afoul of it, right? Because they might be blocked from running a deployment or if they want to use a non-compliant service. And while that might include network resources, it definitely includes managed services, stuff like some of the managed security services in AWS. The other clouds have comparable services that you would want in your foundational infrastructure. Something it almost never includes would be compute and storage, because they're often linked to just a particular service. Now, core services like DNS, that's something that might show up in your foundation infrastructure. You might have a hosted zone specific to each AWS environment. Requirements may differ across staging, QA, dev, production environments. This foundational infrastructure could behave differently, so that's fine. So that's your foundational infrastructure layer. Next up is shared infrastructure. So this is still defined by your platform team and infra ops, but it's guarded by those requirements from security. So what do we think about when we hear shared infrastructure? These are things like stuff that's shared between multiple services or instantiations of templates. So that's going to be networking resources, again, like VPCs or more specifically like load balancers. So you typically want to share load balancers between services most of the time because there's significant cost savings in doing so. It can complicate operations a bit, but there's support for it, and you can intelligently route based on the URL, and so it makes sense to share those resources between services. You don't have to provision a load balancer for every single service running in the VPC. Another thing that will come up here is compute platforms. So Kubernetes clusters, you want to share them between different services, right? That's how you derive your cost savings and operation savings from shared compute. You run multiple services on them. And cost controls are important today now, right? So that's why these things are shared in the first place. And this is not something that most application teams are going to have the expertise to operate most of the time. So that's another reason why you want this shared. You don't want to, at least for production services, you don't want every developer team to have to know how to operate a Kubernetes cluster in order to run a containerized service. So that's why sharing this and then having the operational responsibility be on a centralized infra ops team, which may also be the platform team. That's kind of what I'm trying to allude to in point 4 here. But it's a bit of a contentious point, right? So should dev teams be able to create and manage shared infrastructure? I feel, and I think it's sufficient to most of us here, it's like a lot of things in development, it depends. It depends on the skills in your organization. Some dev teams may be able to handle it, some might not. Sometimes it just depends on how much money you have to spend, how critical that operability of the service is. Like, is downtime going to decimate your business? If you have 98% uptime or something, or cloud costs running out of control, would that be a threat to your business? So that's a lot to consider there, and like whether you should allow dev teams to create what we're classifying as shared infrastructure. Next layer up is really where IDP really comes in. Um, this is what app teams are going to be consuming and making instance of. Infra teams are not going to be running services. This is the infrastructure that the app teams need. So if you're building an IDP, this is where your abstractions and platform capabilities really start to present themselves. And this is also the place where development operations and security require the most collaboration. So this is where everybody in the dev org has a huge stake in how well this layer operates. These resources are going to be operated by developers on the app teams. In most places I've seen, if the Kubernetes cluster goes down, that's a centralized ops team or platform team problem. There's definitely different fields of thought here, but for this presentation, we're going to make that assumption. And then in the workload or the service layer, this is going to be some containerized service, right? So if performance is bad, if your app has some sort of resource intensive query, that's going to fall on the application team to debug. But then if you have many app teams, the platform team won't know what the specific parts that make up that application are or how they behave. So the platform team is not going to be looking at that application code. They're responsible for giving the dev teams just that abstracted way to make sure that they can solve their own problems, but they aren't going to be the first to triage those ops problems. So when we as an industry started coining that term DevOps, there was the idea of developers building and running everything themselves. As that concept matured, platform engineering grew into a more practical application, I guess, of DevOps in a scalable enterprise environment. The platform team gives developers a shared platform and reusable components and templates, but your actual workload, the services themselves, the work itself, you're responsible for running it. So we end up seeing development teams being that on call for their own apps. And this emphasizes the point of making sure that guardrails are provided, that these application teams have what they need to run their service in a secure and managed way. And that's effort. That's work, right? So the platform team really owns these components and templates. And with all that hard work, we want them to be reusable and discoverable. We want those components and templates to be that way. So let's put them in what we call a registry. So what do I mean by a registry? You've got this catalog of your organization's patterns and practices. The interface for this is coming up in the next slide, but let's say you want a containerized service on Kubernetes. You might have another component in the registry for a serverless application or something that runs on VMs. Programming language, like the actual programs you use, might come into play here as well. By the way, any Pulumi component written in one language can easily be used and mixed and matched with another. You're going to want a registry that has all the common patterns that your organization needs. There are 4 specific definitions in our Pulumi terminology that I have to ensure here that we're on the same page. I hope you get the concept of a registry already. We are calling the list of reusable items in the registry, those building blocks of your templates, we're calling those components. And from those, we have templates, which are your blueprints comprised of one, but usually many and usually orchestrated components working together to build out that reusable infrastructure solution. And then finally, we can logically group deployed instances of those templates into services. As a little preview, these can also include configuration specific to the service, so it's all just nicely in one place. Don't worry too much if this is just a bit fuzzy, as I'm going to reiterate it here a couple more times, and I'm going to show you in the demo later. So in order for an app team to deploy a service, let's ask ourselves what type of resources are going to go into this. First off, you're going to have your deployable artifacts of some kind in a containerized service that's clearly a container and some other supporting stuff for the container. It needs to include pipelines or a way to deploy so that the application teams can get their own service instance into production. And then it needs to include whatever they need to operate that service. So that's going to include things like SLOs and accompanying alerts, any sort of telemetry so that we could figure out as an app team what's going on in the application, dashboards, all that. It may even include things like on-call rotations, for example. Like since Pulumi is a multi-cloud tool, you can define PagerDuty rotations, for example, in a Pulumi component or your program. So you can include those operability aspects that app teams need to be successful just right in the template. And last but not least, across all the 4 aspects, the registry, components, templates, and services, security has to be baked in. You can do that using Pulumi CrossGuard, which is our policy as code engine. That's our way of ensuring that whatever application teams are allowed to do at this layer, it's going to be automatically blessed by security so they don't have to go through some sort of manual check the majority of the time. If you have policies in place, components will have been vetted already, and any additional code will be checked proactively before it goes to the cloud. It's that shift left. And finally, at the topmost layer, this is the developer experience layer. If you're making or using an IDP, that platform's a product, and you need to have a product mindset. What do I mean by product mindset? That is the most important thing, in my opinion. It's that product mindset, that customer focus. Often I'll see someone in a platform team have a product role, like a product manager or owner, whatever your organization wants to call it, and they need to be taking in those requirements from the field, from their customers, which are your application teams. Those are the ones that are actually daily using your IDP. And if you want people to use something, what's one of the first things you need? You need to have very polished documentation, because our goal here is we're working to enable self-service. So you want your application teams to do whatever they need to do, and they're able to both self-serve in terms of the capability to discover and deploy a service with your IDP. And part of that is having good documentation there. So if they get stuck or unsure of something or don't know what something does, they don't have to reach out by default to the platform team and request help. Anticipate their questions up front if you can. So documentation and polish is a very important part of the developer experience. As a platform team, make sure you're paying close attention to how clear your documentation is. Just probably want to track how many support requests you're getting for things that aren't written down or were written down, but nobody could find them now. That's a good chunk of what we mean when we say customer focus and product mindset. Lastly here, and I hinted at this before, you need to have some sort of feedback loop. If something's not working for an application team, they need to be able to let you know, and you need to be responsive. One way to do this is allowing outside contributions. People outside the platform team should hopefully be able to make PRs to your platform if that's something your organization is comfortable with doing. If app teams are capable of submitting a PR for the platform, which they should be, fantastic. It'd be great if they could test that in isolation too, but that external help shouldn't be the only way of improving your platform. You should internally always be trying to serve the needs of your customers to the best of your abilities. You want to gather feedback. That's really important. That could happen in, for example, like one-on-one conversations. If the scale of your organization is small enough, you may also want to just make sure you send out periodic feedback surveys asking, hey, how well is this IDP meeting your needs? Surveys can be tricky, and that's an entire topic on its own, right? But they can be an excellent just starting thermometer of just how effective your platform is being. You're going to want to try to keep some internal metrics on your platform. Stats like what's the level of platform usage, how many services are deployed, which components are most popular. I'd mentioned that the DORA metrics can be helpful here. That's DevOps research and assessment metrics. One caveat with DORA metrics is that they only really make sense when you're looking at a single service. You can't compare across services. And the reason here is, like, I'll give you an example, is if you have like a legacy monolith, there's no way that the deployment frequency for that is going to be the same as, say, a fine-grained, small, brand new microservice. So don't use the DORA metrics to compare across services. You end up just drawing false conclusions and going down a rabbit hole. And, let's say a Team Snake is always shipping the same service and it's the legacy monolith, and their metrics are getting worse and worse. It's taking them longer and longer to deploy. That would be something that you want to notice as a platform team, to reach out to that specific application team and ask, hey, is there anything that we as the platform team we're doing or can change to make these metrics less worse? What's making these worse for you? So developers at the top. We observe developer experience tends to break roughly into three different categories. You may not necessarily use all three of these, but you probably want to have them available. You want a web UI, you want a CLI, and then third-party integrations, which make use of tech like webhooks. I kind of trust here at the audience that the web UI and CLI are pretty self-explanatory, but the third party is a bit more nebulous. So think of things like sending a Slack message to an ops channel noting that Team Otter deployed a new instance of the Kubernetes cluster template, or even GitHub integration, maybe sending info into a queue in AWS itself. I don't know. But it's important for your IDP to offer that sort of thing to enrich the developer experience. So I hope I got you all excited and happy and ready to use an IDP. So now I'm going to tamper your expectations a little bit on that. No matter how great you make your internal developer platform, whether it's build or buy, your adoption is never going to be 100%. To borrow a coworker's spark of genius, he likened this to it's like unit test coverage. If you've done application development, you know that 0% unit test coverage is going to end up being a recipe for disaster at some point. You never know what that timeline is, but conversely, 100% is not really desirable either. I'm going to agree with Josh here that the ideal number of unit test coverage is going to be something like, I don't know, 80%, the good old 80% rule. You can't cover 100% of use cases. You don't want to. You're going to waste your time just making abstractions that aren't reusable. Just allow the outliers, let them go. Maybe just stuff like an example, maybe they're the only one running on a specific cloud or provider. It's just not worth making a parameterized abstraction for it. There could be new technologies that are being used in an experimental way in your org. Like, this team is going to try to use a new AI offering. Don't rush out there and add a component to your registry just for them. Wait until there's enough people wanting it and it's going to be widely used to create an abstraction for it. So just keeping an eye on that, and just don't chase 100%. But just watch what the percentage of usage is, though. So, like, how is that trending? Keeping track of what's being used, and essentially your registry inventory of components and templates. That's going to give you like those trend lines and work out what abstractions are working and what might not be working as well. So you can start maybe pinpointing certain teams that aren't using your IDP, and you can reach out to them proactively, maybe do a lunch and learn with them and ask some important questions like, what are you doing today instead of using the IDP, or anything we can do to help? What's blocking you? Because the entire org is a team, right? You all should be going in generally the same direction. So Pulumi, a big part of our mission here is to make this IDP creation and usage in your platform engineering efforts, to make it all easier for you. So we've noticed that that's going to involve 3 different teams working together. You have your development team. They're the ones that are launching applications and services. As the infrastructure team, you're going to want to make sure that's as easy, as secure as possible for them. And you want to ensure that as the development teams doing the work, whatever they make, it meets the needs of security. So they're going to create that golden path of IAC abstractions, and everyone working together in concert with that best class tooling is going to naturally speed things up to meet the needs of the business. Pulumi has 4 pillars that make our platform. First off is that infrastructure as code. I bet most of you know of it and all of you love it. And that's your writing infrastructure as code and general purpose programming languages to create and manage resources. And then second, we have Pulumi ESC, which is our centralized secrets broker. You can authenticate against Pulumi Cloud and retrieve transparently secrets, and use them in your Pulumi programs, put them in environment variables, DRMs, just pass it off anywhere. Easy way to centralize and aggregate your secrets. Next up, we have Pulumi Insights, which is our cloud inventory tool. You can see and search all of your Pulumi managed resources across your stacks. You can even ask our Copilot AI human language questions about your infrastructure. And if you have resources in the cloud that aren't managed by Pulumi programs, if you give us credentials, we can scan, say, your AWS account and retrieve that state data in Pulumi Cloud for unmanaged resources. You can see the percentage that's managed and unmanaged, and just you can keep an eye on your cloud spend from just across your entire org. You can run policies against those discovered resources as they're being scanned in, so you can basically use it as a security scanner, and identify things like old Kubernetes versions. I think the most interesting part of this is now we have visual import. So with those unmanaged resources, we can help on your behalf create very nice looking Pulumi programs just from that unmanaged resources. So it's a very quick way to get your unmanaged resources turned into managed Pulumi resources. So last but not least, and the focus of our demo today here, is Pulumi IDP. That's our vision based on years of experience of what a developer self-service at scale looks like. Real quick, all the stuff that we talked about, we are very API friendly. We have all APIs for all those 4 different areas. And in the interest of time here, I'm not going to go through all of them. But if you have any questions here, you can look up in our docs and check it out. Just a little bit more about our access controls, but again, just running through here. And through all those APIs, you can build your own IDP. You can do it. If you have the time, if you have the experience, if you have the teams, you can make all of this happen with the help of Pulumi Cloud. You could build your own web front end, and you could have a self-service platform that your developers log into. But if that sounds like a lot, which it is, let's take a look at Pulumi IDP. So this is Pulumi Cloud and Pulumi IDP. You'll see that we have the components, which is those building blocks that we talked about uh, just long time ago, it feels. And we have templates, which are those compositions of one or more components into ready to go templates that your app team can come in and deploy. And then we have services. And so all this builds in together into the Pulumi private registry that I mentioned. This is all kind of like hosted by us. You can upload templates into a GitHub repository, and you can publish components, versioned components into the Pulumi private registry, and have that available to your entire team. So let's look at one of these. I'm going to look at this one. And this is just an AWS container service, right? I have a nice little README here that has been picked up from it being published, and I can show you where that is over here. It's just written in Markdown, and this is a component. And this is my starting point here. If you're familiar with Pulumi programs, this should look very, very familiar. This is just a component resource. You may have even used them. That's just a way to logically combine different Pulumi resources into a single resource. And this one is actually composing itself of two other component resources, which I can also go into here and see. So this is just creating a Docker image, creating an ECR repository, putting that image in there, getting it ready. And then from the app deploy, and I'm in my IDE, remember, so I can just go to a definition. You can see here that it's just creating a cluster and a Fargate service based on that image. So this is just a component. There's nothing special to it. I do have to just have a file here called plumiplugin.yaml and specify the runtime so it gets picked up. And then I can just publish this with the Pulumi package add command, and it magically shows up here in this list. And I want to drive this home that Pulumi components, you saw that was written in TypeScript. It doesn't matter that it was written in TypeScript. You can ingest it, you can make use of it in any of the other languages we support, including YAML. So I think that's a really powerful and simple thing that you get just out of the box, just by using Pulumi and using component resources and putting them into Pulumi Cloud. And let me show you a template here. So I'm going to just continue the tradition of this container service. This is actually a template, a Pulumi template, that is using a component in the back end, right, in the code. And so you see what it's doing. You can see that we've mentioned in the README here what this actually uses, which is that app image deploy. And then stack settings is just another kind of meta component that we're using. And I can show you that here as well. You'll see here, this is the README for that this is actually a instantiation of this template, but it's the same concept, right? And again, the code looks very simple. If you've used a Pulumi before, you should recognize what a Pulumi program does and what it looks like. Pretty simple stuff. I'm just doing an import. I'm just getting some config, which may or may not come from ESC, and I'm using that component. I'm specifying it. And all I had to do was add that dependency and set it up as a package. And you'll see here, this is where I'm pulling it from, version 1.1.0. And that is all there is to it. It's really simple. I want to then deploy this as an app team. So I'm going to go in here. It's going to auto-generate the name. You have a few options here nowadays with Pulumi deployments. You can have a Git-backed version that will actually take the template and create a Git repository. You can also do a no-code deployment, which means you're not going to get a repository, but the configuration is going to be stored in a ephemeral is not the right word, but in an ESC environment. So if I create this, it's going to start the deployment like you normally would from New Project Wizard, and I will see that I have created, there will have been an environment created in here. Hope that's impressive. And I've gone ahead here and created that same template here. This is the code that I was showing you earlier. And one thing with ESC, which is really cool, I'm aggregating different ESC environments here into like one big one. And if I go back to my cloud access, which is one that it imported, you'll see how easy it is to give not just Pulumi Cloud access to your AWS environment, but also I can open this ESC environment and run commands against it on my local machine. So the power there is on my machine here. I don't have AWS credentials. I'm just using Pulumi ESC, authenticating to Pulumi Cloud, and getting short-lived access tokens via this ESC environment. And that works, again, across the board. I didn't have to make any changes here. I just had to use this environment either locally or via a deployment. So you can see that I have spun this up. You can see the resources. I can see the graph view. And if you squint or I make it bigger, you can see here exactly where that component is coming to play. You've got that app image deploy. You've got the app deploy and the app image that was inside of that. And there's all of the actual resources that template and those components had. And again, just to drive home here, all the work that we just did was run across policies via crossguard policy as code. And you'll see here that I have a violation set up conveniently, and this is telling me that these components are out of date. So as an app team, I can come in here and say, oh, all right, yeah, I need to work with maybe the platform team or change my code so that I'm using the latest version of these components. So it's not just things that are security related in terms of like having an open S3 bucket. There's also operational concerns here that can be addressed with policies that just, for example, outdated versions, or I can even require your Pulumi program as an application team. I can require your program/template to only use components. Like if you're trying to spin up a resource outside of a component, I can disallow that from happening. And in this case, this was advisory, but I can make any of these policies mandatory, which is, powerful. It's that shift left mentality. Last but not least, we do have services. This is kind of our idea of just like a logical grouping that we allow you to come in here and I'm going to make a team otter, and I can set up some properties here like docs link, which I'll just go to pulumi.com. And I want to add the stack that I just created. Let me try and find it here. Here we go. And since that no code deployment also created an ESC environment, I can try and find that wherever I did it. Maybe that was a different name of it. No worries. Let's choose this one. That's fine. And then I have entities, and once I create that service, you'll see here that I have a nice little view. This is great for the platform teams to kind of logically combine and collate and control, in the sense, all these different services that have been deployed by the application teams. And let's see, I think we are good. We have good 8 minutes. Any questions? I think Tom is typing away there. We do have a massive Java upgrade on numerous repos. We do have different Java versions and different Spring Boot versions. Can Pulumi accelerate this process with its IDP? It can, but not by itself. Um, I may have to, follow up with you on this a little bit, but y- you would have to firstly, define the Java versions and Spring Boot versions, and I think depending on like whether this versioning is something that we could inspect for you, like with Pulumi Insights, maybe. I think the challenge here would likely be how you get this information into Pulumi Cloud and with IDP. Um, there may be some ways to kind of work around that, but that's kind of my initial thought, and maybe Tom is kind of thinking about it too. But yeah, that's a good question, and I think there's maybe some possibilities there, but it's nothing. We don't like check existing dependencies or versions at the moment. It would be something that's kind of built from a component and template from the start. Insight support only AWS Cloud for now. No, it supports more than that. So if we go to accounts, you'll see that we have AWS, we have Kubernetes, we have Azure, OCI, and just I'm pretty sure this just came out, Google Cloud. So you can do insight scanning on any of those 5 clouds, and Kubernetes too. And it will just start doing the scan. And since I have a few moments here, I can try and show you real quickly an interactive import. We'll see how fast this goes, but I just picked something random, so bear with me. And there you go. I want to enhance this so it doesn't look silly. Enhance is just kind of an AI way of just making this nicer and giving it human readable variable names, and also throwing in some comments here. But you see, like I pushed a couple buttons, and this made me a Pulumi program in any of the languages that we support. For this container definition and ESC task definition. So you could always do this via the CLI, but it doesn't have the AI portion as far as I remember, and just this is all built in, and in literally 3 clicks or so, I can get a working Pulumi program. I think that's just fantastic, man. I mean, I don't know what else to say. That just makes things so much easier to, once you have stuff scanned into Pulumi Cloud from Insights, you can just create that Pulumi program and start creating components, right? You can easily say, maybe we just even with Copilot AI with this program, turn it into a component resource, and there you go. You could start publishing it, for instance, and just codifying what your org needs for things like this ECS task definition, which is not the best example I chose randomly, but think of it as like if you have an EC2 instance or something. So can we share after creating templates or components are published online with the Pulumi community? Yeah. So there are public examples of this, just even from Pulumi, but you are more than welcome and encouraged to publish them publicly as well. There's nothing stopping you from publishing your own components or templates, and depending on your level of support or addition of Pulumi Cloud, I could just come in here and say, oh, I want to add your source, and if it's a publicly accessible GitHub repository of templates of Pulumi templates, they would show up here in the templates view. It'd have a different publisher, it'd have your publisher name, right? But yeah, I think that's a very viable way of spreading the love. Yeah. Right. Let us wrap things up here and get done right on time. This is not the end. Continue your Pulumi journey. We want you to join the Pulumi community Slack if you have not already. Just go to that slack.pulumi.com and join Platform Engineering channel. I am there. A bunch of us are there. Tom, I believe, is there. You know, just it's a nice little place if you have any more questions or want to follow up with something comes to mind later in the day. We're there for you. Just add us or just hit us up in that channel. And then sign up for a Plumi Cloud account if you have not yet. Try it out. It's a free forever individual account that's available. And once you sign up with an organization there, or just once you just sign up, you get a 14-day free trial of the SaaS product. No obligations, but it's there for you to try out. You'll get Pulumi Insights, you'll get ESC, you'll get deployments, you'll get IDP, everything. And lastly, again, it's a journey. Join us for an upcoming workshop. I know July 30th, we have IDP strategy, planning self-service infrastructure with Mitch and Angan. And then August 6th, I am back with you and Angan. We're going to talk about infrastructure components and templates in more detail. It's going to be more code oriented, I believe, than me talking for 30 minutes about thought leadership stuff. So hope to see you there. And I really appreciate you all taking the time today. Have a good one.